Welcome to this explainer. Today we're totally dismantling those supernatural myths surrounding the Great Pyramid of Giza, and instead we're going to uncover what might just be a brilliantly hidden, massive industrial machine. We're putting the spotlight on a revolutionary engineering theory that honestly changes everything we thought we knew about how this ancient wonder was actually built.
To really appreciate this, let's just anchor ourselves for a second in the sheer scale of the monument. 5 million tons of stone, stacked 146 meters high over 4,500 years ago. Think about that. For over 3 millennia, it was literally the tallest man-made structure on Earth.
So here is the ultimate engineering paradox. How do you lift a 60-ton block 146 meters into the sky using literally only copper and wood? The builders didn't have iron, they didn't have pulleys, well, pulleys as we know them today, and they didn't even use the wheel. Look, if you've ever struggled to move a couch up a flight of stairs, just imagine hauling blocks that weigh as much as a modern commercial airplane into the sky.
Section 1. The human supply chain. To solve this mystery, we first need to look at the people who actually built it, and we can finally leave those Hollywood myths of alien levitation and tortured slaves firmly in the past.
Because we actually have the receipts. The diary of an ancient middle manager named Mir survives on papyrus, and it reveals a highly organized state-run logistical machine. His crews were moving heavy limestone across a now-vanished branch of the Nile in strict 10-day cycles. They'd load 80 tons of rock on day 1, sail across by day 3, and unload at Giza harbor by day 5. This wasn't some chaotic labor camp. This was the birth of state-level logistics.
And to power that massive human machine, the state provided 2 tons of meat. 2 tons every single day. We know this because archaeological digs at the workers' city found huge bakeries and the bones of tens of thousands of cattle and sheep. Plus, skeletons found there show expert medical care for broken bones, including amputations that successfully healed. So these workers were a highly valued, well-cared-for asset.
Moving on to Section 2. Ramps and impossible math. With the human element grounded in reality, we have to ask, how did they physically drag these immense stones upward? For decades, textbooks just said ramps, but when you actually crunch the numbers on that, the math completely falls apart.
Check this out. An external ramp gentle enough to haul stones to the top would have to be 1.6 kilometers long. That would require more building material than the pyramid itself. Plus, a giant ramp covers the corners, meaning builders couldn't check their sight lines to keep the pyramid's angle straight. It makes no sense. But on the right, we have French architect Jean-Pierre Houdin's internal edge ramp theory. It sits just inside the outer walls at a 7% incline, perfectly contained, leaving the outside completely open for constant geometric checks.
Which brings us to Section 3, the machine inside. This is a total paradigm shift. Houdin proposed that the top 2/3 of the Great Pyramid were constructed from the inside out.
Now you might be wondering, how do you drag a 2.5-ton block around a sharp 90-degree internal corner? Well, at each corner, the theory requires open notches in the outer casing, basically gaps in the facing stones where the ramp would round the bend. Workers would use simple wooden hoists derived from ancient irrigation tools like the shaduf to literally pivot each block around the turn before the ramp continued upward. Once the level was finished, the notches on that tier were filled in and sealed, and the builders moved up. Construction proceeding, in effect, from the inside out. It's so clever.
Section 4. The Grand Gallery counterweight. So the internal spiral beautifully solves how to move those 2.5-ton limestone blocks, but it doesn't solve the harder problem. The King's Chamber required massive granite roofing beams quarried at Aswan, and some of these weighed an estimated 60 tons each. They had to somehow be hauled to the pyramid's center. These are far too heavy and way too wide to ever navigate a narrow internal ramp corner.
And this is exactly where Houdin points to the Grand Gallery. You know, that soaring, corbelled corridor that leads up to the King's Chamber? Rather than reading it purely as a ceremonial passage, Houdin calls it an industrial vestige, the visible remains of a machine. He proposes the Grand Gallery functioned as the track for a massive counterweight system. Sand-filled weights and sledges ran on a slide, using gravity to help hoist those massive 60-ton granite beams into position. Actually, the granite plugs found at the base of the ascending corridor might be the physical remnants of that exact load-bearing mechanism. He even points to the narrow shafts leading from the Queen's Chamber, suggesting they were an internal communication system, like an intercom, allowing workers to coordinate the counterweight's timing. Section 5. Testing the stone.
Taken together, it is a genuinely elegant answer to two separate engineering problems using features that already exist inside the pyramid. But hey, an elegant model is still just a model, right? The real test is whether the ancient stone actually agrees with it. Back in 1986, French engineers used microgravimetry to scan the pyramid. They were originally hunting for secret treasure chambers, and when they didn't find any gold, they kind of deemed the mission a failure, but they were completely unaware of how perfectly their findings would later fit this new puzzle.
Because the physical evidence is staggering when you look at it. That 1986 scan, it actually showed a 15% subdensity void, forming a perfect 7% spiral, right where Houdini predicted the internal ramp would be. Plus, inside the Grand Gallery, there are long grease scratches and chisel marks, exactly where a counterweight trolley would have repeatedly scraped the stone. And the craziest part? Egyptologist Bob Breyer actually climbed up to one of the theoretical corner notches and found an unmapped 9-meter empty room, a literal leftover space from turning the blocks.
It's really something to see how this evolved. On the left is the original, hand-drawn 1980 sketch by Jean-Pierre's father, Henri Houdin, who first had the internal ramp idea. And on the right, that same idea, transformed into a fully validated virtual simulation by Dassault Systèmes, a top-tier aerospace and industrial 3D software company.
These engineers didn't just make a pretty picture. They ran the hardcore physics. They tested the friction, the weight limits, and the structural stress on the granite. And they confirmed that mechanically speaking, it completely holds up. The physics of the counterweight system and the load limits of the internal ramp are 100% realistic. The machine inside the mountain works.
Section 6. The voids still hidden. Even after seemingly cracking this engineering code, the Great Pyramid is still not finished revealing its secrets.
Enter the Scan Pyramids project in 2015. They used Muon tomography, which sounds like sci-fi, but it's basically using subatomic cosmic ray particles that harmlessly pass through solid rock. By tracking where these particles pass through easily, scientists can map out hidden empty spaces without ever lifting a single stone.
And what they found in 2017 absolutely blew people's minds. They discovered a massive, completely unknown void. We are talking about a space the length of a cathedral nave, at least 30 meters long, sitting directly above the Grand Gallery's counterweight system. Is it a relieving chamber to displace weight? Is it another part of the internal ramp system that was walled off? We literally have no idea.
Which leaves us with one incredibly awe-inspiring question. What lies sealed inside that 30-meter void that no human eye has seen in 4,500 years? This wasn't just a tomb. It was a vast machine that forged the logistics and bureaucracy of an entire civilization. So what else did they leave hidden in the dark? Think about that for a while. Thanks for joining me on this explainer.